Hey all. Today we're going to talk about access modifiers and some optional modifiers in Java. My claim is you guys have seen some of these, but we haven't really spent a lot of time digging into it. And now that we're kind of getting into objects, we're starting to be at a place where talking about these modifiers makes a ton of sense. So the first thing I have here is I have a just a new project that I've created that so far only has sample code in it that just prints out modifiers. So I'm going to do the same thing I always do with a new project. I'm going to take my example code. I'm going to hit run on it. I'm going to make sure that IntelliJ is working and that things are outputting in Java for me, so that I know at the very least that what problems arise are from me and not from the IDE. Okay, so we got that working. Great. So the example here I'm going to use is the idea of creating some bank accounts. So in my kind of world here, I'm kind of pantomiming like writing the back end of some financial institution's software. So I'm going to make a couple different account types, and we're gonna talk about how access modifiers affect those things. So the first thing I'm going to do is I'm going to go in here and I'm going to say I want to make a new Java class, and my Java class is going to be called account. Okay, so this is a public class, which means the public here is the access modifier for this. So that means that this is a class that I can have access to from anywhere. So that's kind of our first modifier, is this public modifier. You should be really careful with these. A public modifier means that this thing can be changed from essentially anywhere in the code. So you should only leave things public that you intend to have basically no protections on. So my public field that I'm going to enter in here for my account class is every account's going to have a nickname. And I'm comfortable leaving that pretty exposed because I'm not going to use that for anything important, right? This is just going to be what the user calls their account. And so if this gets screwed up someplace in the code, it's not real high consequence. So that's going to be my public thing. So a public field is accessible from anywhere, essentially. What I actually mean by that is any Java code that's implemented that includes this class will have the ability to modify this nickname thing. This is probably a bad idea even for a nickname, but it's an example that I think I can use reliably. Okay, so that's my accessible anywhere field. Next, I'm going to create something that's kind of the opposite, which is something that's like extremely private. So private things are only going to be accessible from within the same class. And so the modifier for accessible within the same class is private. So I'm going to make a private integer that I'm going to call pin. So I should hope that it's obvious why I want to keep pin as a private thing. Do please note that this means that this is not going to be accessible even from some subclasses. What that means is that if I make a new kind of an account that's specifically like a savings account or something, that savings account is going to come with a pin, but that savings account isn't going to be able to change that pin willy-nilly. This is where we're going to use a getter or a setter method. And for a pin, like personally, the way I think about code, I probably wouldn't write a getter method for a pin. So what that would mean is that even though a savings account might have a pin, it probably wouldn't have a way for anyone to get that pin out, right? Why I would do that? Like, honestly, the only thing you should be able to do with your pin is reset it. We should never, essentially, we should never be able to tell you what your pin is outside of the account creation process. So my claim is that this is probably how most banks kind of work things. When the account is initially created, there's a line in the like account creation step that sends instructions to the computer to mail you your PIN. So that PIN is created that one time. As it's created, a piece of mail is generated. That goes into the mail system. You get that piece of mail. That is the only time that even the bank is really aware of what your PIN is. Then, if you reset it, there's another thing that either generates a piece of mail to send to you or just allows you to set your PIN. So that's kind of my thought on safety. A middle ground for this, something that's accessible from within the same class and also subclasses. Oops, classes, I promise I can spell. Okay. I'm gonna have to remove the same class idea here because that's gonna be correct, but I'm gonna expand it. So this is gonna be accessible from the same package and also any subclasses. This is our keyword protected. So protected is the access modifier that says anything that's in the same code group as this, which is what a package really is. So a package is just kind of a group of related code. So anything within the same code group or a subclass, even a subclass that's not within the same code group, is going to be able to change this. So a thing that I'm going to kind of think of as being probably protected is going to be, I'm going to have ways to change the balance of an account. So I'm going to put balance changing as a protected value, and this is going to be a double. Okay, hoping that makes sense. And then we've got one other one, which is the package private, which is this is the default, and this is accessible from within the same package. And this is where we just don't put an access modifier. So something that ought to be accessible from within the same code group, but not necessarily subclasses. These ones I actually kind of have some trouble generating, if I'm being honest. So I thought about it for a minute, and what I came up with is that something that's accessible from within the same package for my bank account example might be an overdraft limit. That's something that maybe the subclasses have no business modifying, but that code within the same package, right, which is kind of like my account management software, that might need to modify. So I'm going to call that an integer, and that's going to be an overdraft limit. Okay, so these are kind of our 4 access modifiers. So public, anybody can grab it, no problems. Private, it's only accessible from within our same class. Protected, it's accessible from within the same package and also any subclasses. And then package private or default, which is anywhere in the same package. So this is sometimes called package private. Which is just the default value. Okay, so that's my kind of access modifiers for variables. Now, those same access modifiers also work on classes. So these same things work with a class just as well. Okay, now optional modifiers that you can add to a class. So that's things that could go right here. Things that could go right here could be final or abstract. So if I put final here, what that means is we're not making any other kinds of accounts. There's only accounts. So this is saying that there's never going to be anything that's an account that's not also just this class. What that means is I can't generalize this thing later. I can't inherit from this. So I can't use this as kind of an intermediate step. What that would mean is a saving, like if I make a variable for a savings account and a variable for a checking account, those would both have to actually be accounts. I couldn't make a new kind of account that's a savings account and a new kind of account that's a checking account. I think that would be a bad choice for this. So I'm going to say that this class shouldn't be final, but that's what final would mean. So I'm going to add that up here. So final applied to classes would mean that we're never going to extend this class. Okay, the other one, which is the one that I'm going to find myself using quite a bit more often, because I find myself very hesitant to limit myself from extending a class. I'm much more likely to say, I want this class to exist, but I'm never actually going to make one of these. I'm only going to make subclasses. So that would be the case that I'm much more likely to use here. So if I put the word abstract here, so abstract applied to classes means there can never be an object created from this class. Now, that doesn't mean there can never exist accounts. It just means that you have to extend it first. So what that would mean is I can create a new kind of account called a savings account, and then I can make a savings account. I can create a new kind of account called a checking account, and then I can create a individual checking account. That's going to be a thing that I'm going to do much more often. So like when I'm designing games or when I'm designing software, I make lots of abstract classes. Okay, so I think abstract is a good modifier to use here. Because we're never going to create a bare account. We're only ever going to create either savings accounts or checking accounts or maybe different kinds of accounts. But I don't think that a just bare account can exist. So that's what I'm going to choose to use for this one. So for our class modifiers, we have final and abstract. Now let's talk about modifiers for methods. We've already used some of these before. So the first one to talk about is let's see. I don't have a constructor in this, so let's make ourselves a constructor real quick. Right now it's not doing anything, so obviously this isn't going to be a working class at the moment. But when I want to make a method in here, so let's say that I want a method for changing my pin, right? So that's going to be a thing that I really want my subclasses to have access to, probably, right? So I've got my private variable pin, right? Then I probably want to make a protected method called setPin. So I've got my access modifier. I need my return type in here, so this is going to be a void method, right? So it's not returning anything. We'd have some process in here for setting our pin. I'm going to leave that off for right now because I'm really just talking about the modifiers. So modifiers that could go in here are static, which we're going to have a major problem with right now. So I'm just going to put notes here. So static methods can only be used by the class as a whole. So what that would mean for my case here is that we could only set the pin of kind of all of the class, like of the idea of an account. I could never set it for individual accounts. That would be a terrible choice here, so we should delete this. That's not going to work for us. Good examples of things for which static methods ought to be a good idea. in your main. Probably make a static method there. Your main method's probably a good choice to have as a static method. Why? Well, because I'm never going to actually implement a class main, and so I don't need it, right? I just want this to run when I run the code. Other things that are good examples for static methods are like helper methods, like parsers. So if you want to be able to generate an account from a JSON file, that would be a pretty good thing to have as a static method. Okay, other options here. We could make a final here. So final methods can't be overridden in subclasses. That means if I make a set pin method here, even if I make a savings account later, that savings account can't have a different way to set its pin than an account does in the abstract. This is probably a great choice here. So I might say I want this to be a protected final method, right? And what that means is that this method just can't be changed later. Even if I make a savings account that's a kind of account, I can't have it set its pin any differently than I would for anything else. This is actually probably a really good choice for this example. All right, other options. So in place of final, I could put abstract. So an abstract method can't have a body and must be overridden in a subclass. Essentially what that means is I don't know how accounts would have so if I put abstract here, right, I'd be saying, I don't know how each account gets a pin set, but you have to tell me when you make that kind of account. So if you make a checking account, that checking account would have to have a set pin method. That set pin method could be different between the checking account and the savings account, but you must tell me how that works. This would actually also be a pretty good choice here, depending on how I intend to implement the rest of this code. Then there's a couple more that are probably bad choices for this example. So the other ones are synchronized. So synchronized methods are used in multi-threading. And essentially this means that you can only access this with one thread at a time. This is a great thing to have, but not real relevant to us today. That's a topic for later investigation. Likewise with native. Native methods are real weird. I'm not good at them, but they do exist. So I need to tell you about them right here. Native methods are for writing methods in other languages. So if we wanted to write a C method and then implement it in our Java class, we can use native to do that. Again, this is a thing that I think is well beyond the scope of a beginner course in Java, so I'm going to kind of leave this off. I think for our choices here, final or abstract probably makes sense. The other thing is we could just leave it. It doesn't necessarily need an optional modifier. These are not necessary. They're only optional. I would say for this, final or abstract are probably actually really good choices. Okay, let's talk about options for variables. So these are optional modifiers for variables. So these are not access ones. So we have final. A final variable is basically a constant. It just can't be changed. So final variables can't be changed. Why might you do this? You might do this if, for instance, uh, your your account needs a creation time, and you never want that to be modified. We could go ahead and use a final variable for that. Those are only changeable the one time and can't be changed otherwise. So that's a great choice. Other things that we might use final variables for are like mathematical constants. You might create the account and set its interest rate forever. That would be another kind of final thing. Static things are shared by all instances of the class. This would be a bad choice for accounts, right? Like, there's no reason that I would use a static variable in this context. They can be nice to use in some contexts, especially in the context of I'm not actually going to create one of these things. So, like, if you have a kind of an abstract game class that's running everything, you could make some variables in there static. Again, I probably be a little bit cautious with using these. There's a place for them, but they're if you're making instances of a class, these are probably going to be more confusing than anything because they are shared by everything. You could easily screw up a game by making, like, say, all of your mobs have a static variable that's their hit points. Then damaging one mob would damage all the mobs. Same with, like, durability on weapons or something. That's a cause of some confusion. I tend to use lots of static variables at the beginning of the course, and then as we progress, I tend to use fewer and fewer of them because mostly I'm going to start making objects as we go on, and I didn't need to do that at the beginning of the class. Let's see. There's also there's a couple that I don't use very often. So the other ones are transient. So transient variables are skipped during serialization. This is not a topic for today. This is just a thing that exists. I'm not using these often in code that I'm writing. I don't expect that you'll be using them very often. They are definitely a thing you could dig into if you wanted to, like, really get into the deep guts of Java. And then there's another one, again, also not super commonly used by me, that's a multi-threading thing. So volatile variables are kind of visible across threads. I spelled visible wrong. I got it right. Oops. This is something we'll talk about more when we get to multi-threading, but for right now it's not hella important, so just know that they exist. And these modifiers would go right here. So I'm actually going to say that in my example, I really probably shouldn't have any of those things here, except you might do something real bizarre and set your overdraft limit to a final thing, or you might say, all right, all accounts of this type have the same overdraft limit, so we might just set that as a static variable. Again, that's probably not a good idea in this context, but would maybe be a thing that you could use. So that's kind of all of our access modifiers and our optional modifiers. In general, with access, the rule with access ought to be you should restrict it as much as is possible while keeping your code running. So that means creating lots of private variables for the most part, and then using getter and setter methods. Those getter and setter methods, like for my pin, I'm never going to write a getter method for that here. I'm only going to write a setter. That's because I don't think that I should, as the bank, have a way to know what your pin is on your account. In fact, I probably should be storing it in some kind of a hash rather than storing it as in this case, a plain integer. We can also, in our setter method, we can put restrictions on how that thing is set. So that's why the setter method, as opposed to just allowing people to do like, you know, checking account dot checking account dot pin equals new, like a new value for it. That's generally speaking a bad idea. You probably want these getter and setter methods so you can do a little bit of validation to make sure that it's being set to the correct thing. Thank you guys on this. I realize there's a lot of stuff in here and not a lot of example. This is something we're going to play with some more in class. I encourage you to, ask about access modifiers, ask about the kind of optional modifiers as we're making things in class, because you're really going to learn to use these as you write code. Thanks, guys. I will catch you on the next one.